because that was the story of society after society around the world. On almost every continent, there's a good example of a civilization that undermined their longevity due to degradation of their farmland. And, part of the problem is that the processes of soil degradation play out fairly slowly. They're rarely the crisis du jour. And you can find examples through history all the way back to Plato in classical Greece of people who kind of put the story together and understood what was happening slowly over time. But, slowly unfolding crises are rarely sort of dealt with as an immediate problem.
Welcome to the Real Organic Podcast. I'm Linley Dixon, co-director of the Real Organic Project, a grassroots, farmer-led movement with an add-on organic food label that distinguishes soil-grown crops and pasture-raised livestock. You just heard from author, geologist, and professor of Earth and Space Science at the University of Washington, David Montgomery. David has a lot to say about the importance of soil health to the success of every civilization that's ever lived on Earth, and most importantly, ours. But before we dive in with David, we'd like to mention that all of our podcast episodes are also filmed. And if you'd like to watch our guests in person, please head over to our website, realorganicproject.org, or find us on YouTube. Now let's get back to my co-director Dave Chapman's interview with David Montgomery.
So I'm talking to David Montgomery today. David, thank you for joining me. I consider you to be one of the great educators of our generation about soil and all the ways in which that impacts us and the ways it might impact us in the future and the ways it has impacted us in the past. So
great. Well, thank you. It's a pleasure to talk to you, Dave. And, I consider myself a student of the soil, always seeking to learn.
Yeah. So you've put out 3 books, one with your partner, Ann Bickley, The Hidden Half of Nature. Your first book was Dirt, The Erosion of Civilizations, and your most recent book was Growing a Revolution. I know you're working on a new book, and we will talk about that a lot. But, just to help familiarize people, could you talk a little bit about those 3 books? And maybe even, I'm curious, what got you to be writing so much about soil?
Yeah, well, happy to talk about those books. I've spent a lot of the last 10 years investing nights and weekends in pulling those stories together. And Ann and I refer to those 3 books as our Dirt Trilogy. And when we started working on it, we're not intending to write multiple books on soil. But the first one, Dirt, the Erosion of Civilizations, is really the kind of book that you might expect a geologist like myself to write about the soil. My background is in geomorphology, which is the kind of geology that looks at what shapes the surface of the earth. And that's how I got interested in soils in the first place, was sort of looking at natural processes of soil erosion. And I got very intrigued with work that I'd seen, in books that have been published for the last 150 years occasionally, looking at the effect of how farming practices have influenced soil fertility and how soil degradation has influenced the longevity of civilizations. Looking at places like Syria and Libya today as places that were, farming powerhouses in the Roman Empire, but have a hard time supporting their people today. And I got intrigued by that and that book really looks at the backstory of how societies damaged their soil and undermined the prosperity of their descendants in the process. And as I was finishing that book, Ann and I bought a house in North Seattle where we live. I teach at the University of Washington, and she's a major league gardener. She's a biologist, and she wanted to reshape our yard. And as I was writing this book about the degradation of soil in past civilizations, she was restoring fertility to our worn-out, degraded urban yard. And I was astounded at how fast she was able to do that. And that led us to collaborate on The Hidden Half of Nature, which looked at more sort of the new science of microbial ecology and what it is that is actually going on in the soil as we rebuild organic matter, as we can rebuild its fertility. And I got very intrigued when we finished that book up in looking at whether or not the kinds of things she had done to the soil in our yard could be done on farms around the world. And that led to Growing a Revolution, really looking at whether intensive composting and mulching and cultivating beneficial life in the soil, how far could that actually get us agriculturally to reverse the problems I'd written about in that first book. So this Dirt Trilogy sort of is It's kind of an intellectual journey of a geologist and a biologist going from looking at the degradation of soils to the more optimistic, forward-looking question of what could we do to actually rebuild the fertility of our farmland, to rebuild the health and fertility of our soils, and how amazingly fast we could actually do it. So it was an unintentional trilogy with an interesting arc that went from sort of deep green pessimism to what we might call bright green optimism in the end. As we realize that there's a lot that actually really could be done. So
I think it's so important, and to connect those three different stories that are often isolated. Let me ask you a question. When I read Dirt, I was struck by the fact that these civilizations that have stumbled and really, passed from being these powerhouses to being deserts now, nobody thought it was going to happen there at the time. They were just in the height of their power, and their population was booming, and so farming was growing. And I get the same sense from us, from America, that we so take for granted our position of dominance in world agriculture. And I'm curious if, as you've researched this, have you been haunted by the realization that truly things can change for the worse?
Oh yeah. I mean, that haunted me a lot in putting the story for Dirt together, because that was the story of society after society around the world. On almost every continent, there's a good example of a civilization that undermined their longevity due to degradation of their farmland. And, part of the problem is that the processes of soil degradation play out fairly slowly. They're rarely the crisis du jour. And you can find examples through history all the way back to Plato in classical Greece of people who kind of put the story together and understood what was happening slowly over time. But, slowly unfolding crises are rarely sort of dealt with as an immediate problem. And yet, even a slow crisis, if the sign of the change is always degradation, it just takes longer for a slow change to add up to a big effect than a rapid change. And I think that's one of the things that got me into thinking about this problem so seriously, is that as a geologist, I view the last 10,000 years, the entire period of human agricultural history, is just like yesterday morning in terms of the time that the ecosystems have been around, that plants have evolved relationships with the microbes in the soil, that people have been figuring out how to feed themselves in this world. Agriculture is actually a pretty new endeavor for humanity when you look at it through a geological lens. And when you look at the problems and processes of soil degradation, the idea that it can't happen here is really rooted in taking the soil for granted. In most of our daily lives, it doesn't change all that fast. But you go talk to, sort of older farmers who had really good fertile soil in their youth, or remember the soil their grandparents had when when the soil was first worked in, say, the American Midwest. It's really changed over generations, and you can see that over the course of a lifetime, but it's really hard to see year to year. But those changes matter and they add up. But most importantly, I think they can be reversed. And that's where I've gone from being, an admitted pessimist on the problem of land degradation to now being sort of what I might consider a willful optimist, because I think we can actually solve the problems, we can fix the problems, we can turn it around. But what it takes is not taking the soil for granted. We've got to reframe how we think about the soil in agriculture across the board. And that if we do, we can harvest the benefits of healthier, fertile soil. And there's a whole host of other benefits I wrote about in Growing Revolution that sort of flow from that as well, in terms of reduced pollution, enhanced biodiversity, arguably food that's more nutritious for people. There's lots of other reasons we could sequester some carbon in the soil. But when you look at it from the long-term lens of a geologist thinking about the continuity of civilization, the foremost reason we should invest in rebuilding the fertility of our soils is so our descendants will be able to keep feeding themselves.
So one of the things that I run into actually quite a lot is this confidence that we will invent our way out of needing soil. And, of course, hydroponic production. And, they're quite serious about this, that we're going to replace agriculture basically with factories that produce food. And do you think that's a realistic, prospect?
Well, I think that the only realistic prospect for that to be true, literally, is when we genetically engineer chloroplasts into the human body. Then we won't need soil and we won't need food. We can just go stand in the sun. But in all seriousness, I think that's a very misguided kind of view in terms of having blind faith in technology to sort of solve the problems. If you look at what makes food nutritious for us, this is the subject of the book that Ann and I are working on now in terms of how the soil relates to that. There's all these interrelationships between a plant and the life in the soil and the minerals in the soil and what a plant makes to build its body, how it defends itself. There's all these cues that have evolved over 450 million years of time when plants have been partnering with fungi in the soil and bacteria in the soil that have sort of set up a lot of those processes that lead to nutritious food. And I think that the idea that we'll be able to engineer our way out of needing or relying on the soil, we could do that, but would we be healthier? Would we be getting what we need from the land, from our food? And is it the most efficient way to do it? You look at hydroponics, for example, and just take the example of the mineral micronutrients we need in our bodies, things like maybe copper and zinc. They're in soil particles. The fungi in the soil, as we wrote about in The Hidden Half of Nature, help get those minerals out of the soil particles and deliver them into plants in exchange for a cut of the photosynthetic harvest that plants produce with their monopoly on photosynthesis. Fungi can't feed themselves. They rely on decaying organic matter, once living plants, or the exudates from living plants that they push out through their roots into the soils to partner with microbes, like fungi and bacteria in the soil. Those partnerships are so intimately related and hardwired into plant health, and as it turns out, that translates over into livestock health and human health, although indirectly, and in ways that are harder to directly establish, but you can trace the threads nonetheless. That the idea that we could go simply to essentially soil-free farming and think it is as good as farming in rich, fertile soil, I think it's a deeply misconstrued and misguided view.
Yeah. I've actually heard it said more than once, it's not as good as, it's better than. And, it's a really interesting thing because we are so enamored of our information technologies. I heard a really interesting talk by a major investor in hydroponic production on a massive scale. And he was saying, finally, he said for 2,000 years, all we did was mechanize the ox. And, agriculture really didn't change, wasn't transformed in the way almost every other human activity was by information and information growth. He said, now it's happening. And we're starting to, learn how to control plants and how to, control every input, the water, the light, the nutrients, and we're getting really good at it. And I was struck because these are not stupid people. These are really, really clever people. And I was struck by, but I'm not convinced that they're wise people.
Right. That's exactly the distinction that I think is pertinent here. Technology is something that can either help or hinder with meeting an objective depending on the problem you're actually trying to solve and how you go about doing it. And the view that I came to in writing Dirt, the Hidden Half and Growing Revolution was essentially we need to take some of the wisdom that's embodied in the practices like crop rotations, practices like cover crops, practices like companion cropping, relay cropping. There's a whole slew of sort of traditional wisdom-based ideas that the modern science of ecology is starting to explain sort of how and why they work in terms of the symbiotic relationships between soil life and our crops. We need to take that kind of ancient wisdom and couple it with modern technology, not replace it with modern technology, but essentially figure out, if you look at doing a sort of a census, a microbial census, if you will, on a healthy farm soil, half the species will come up as unknown, unidentified. We're sort of looking at this black box of the soil. We don't totally understand it in a way to think that we can engineer it. And I think there's very sound reasons to suspect that the idea of sort of finding, even the magic microbe to use as an inoculant is sort of a misplaced thing. There's communities of life in the soil that a lot of the beneficial effects tend to flow from. And I think some of the new sort of efforts to engineer designer microbes that could solve certain agricultural problems are running into field trial problems, because when you take a microbe that does very well in the lab and you put it out in the Wild West, the jungle of the soil, they'll often get eaten, right? I mean, there's community dynamics that go on. They have to survive and collaborate with others, play well with others, to really generate the beneficial effects that I think we're seeing through the kind of practices that cultivate the beneficial life in the soil, which is actually different crop by crop. I mean, plants are putting out different cocktails of exudates to attract different microbes, the same way that, say, a company might put out different incentives to try and attract different kinds of workers. And you need a good team to actually have, in almost any kind of a business, you need a good team to actually succeed. And a plant is not unlike that. They need good partnerships with beneficial microbes in the soil microbes that actually do them good on average. And they tend to try and recruit particular microbes with particular exudates. They're building a team. And so when we think about how best to approach that problem, the idea of finding sort of the inverse of germ theory, the idea that we can take out a particular bad actor pathogen and solve a disease problem, that kind of works for a lot of pathogens. But if you're thinking about how do you control or prevent pathogens from having access to your crops, or even to your own body, if we extend the argument to the human gut, it's about cultivating a diverse, beneficial community of organisms that reduce the opportunities for pests and pathogens to actually come in and take over. Right.
So building a different ecosystem, a more complex one, hopefully.
Yeah, the sort of a general rule of thumb is essentially an abundant, diverse community of microbes in the soil tends to promote the health of the soil and the health of the crops that are growing in it. But again, it's you want a different community depending on which crop that you grow. And it's amazing how fast some of the microbial communities will change through a crop rotation or sequence. But with sort of intelligent tinkering, one can figure out how to build that beneficial, dynamic, and crop supporting system in an agricultural soil, which is the complete opposite of what happened in many of the places I wrote about in Dirt. And it's the opposite of what you would find on most conventional mainstream farms in the Western world today, where we over-till, we over-fertilize, we are too much reliant on pesticides, which comes as a consequence of the first two. But there's a different way to think about it and a different way to approach it.
Yeah. Well, I want to go to growing a revolution, but just one last thing, because I think it's important. The reason that we need to grow a revolution is that I feel that we really are in a struggle for how will agriculture be done by human beings on Earth. And, there are people whose vested interest is enormously, they're very powerful, and there's a lot of money involved. More money than we can actually imagine, I would say. Not nearly as much money as there are microbes in the tablespoon, but it is a lot of money. And that's what we're up against is, agriculture is the market that's not going away. Everybody has to eat. So one of the things that is said to counter the kind of statements that you're making in this talk about a revolutionary way of growing food is that people who don't want to adopt these new systems are Luddites. They're blind people who are throwing their clogs in the machines because they don't want the competition.
Right, and that's what sort of a pet peeve of mine is people arguing that that using the latest knowledge in sort of soil ecology is equivalent to wanting to go back to 18th century farming methods. No, that's kind of crazy. The real question is, how will we apply the technology that we've been developing? So, I mean, there are examples of microbial inoculants that have been really good and that actually have very positive benefits, usually targeted for specific crops and specific problems in those crops. But there's other ways in terms of practices. I tend to view this sort of the real choice in terms of the next 100 years of agriculture as sort of a stark, framed in stark contrast between reliance on practices and reliances on products, in the sense that there are those who have a very strong commercial interest in selling farmers' products, whether nitrogen fertilizer, new kinds of pesticides, new cocktails of pesticides. They have a very clear vested economic interest in getting farmers to use more of them because they're selling them. And we need products to do certain things. They provide good services for some things, but the question is, how much should we rely on them and those kinds of products as the front line of agricultural production? On the other side, there's the idea of practices, which would be things like cover crops, crop rotations, things a farmer can be taught and that they can learn and they can do without necessarily paying anybody after that, maybe that first seminar to figure out how to do it, or that $10 on a book that might teach you what those principles are. We can teach practices, and that has been a big problem in terms of promoting them, I think, in agriculture for the last 50 years, because it's difficult to monetize the distribution of practices. It's very easy to monetize the distribution of products. That's built into the nature of the beast. And so I think there's a really big opportunity to rethink the sort of relative mix that we've relied on for the last 80 years in conventional agriculture, and to think about how could we readjust some of the practices that are used so that the products that one can layer onto that might be more beneficial and constructive over the long run. Whereas what we've done for the last 80 years with too much tillage, applying too much nitrogen, and applying too many pesticides to our agricultural lands is we've radically changed the soil biology that lies at the root of soil fertility. When I was in graduate school, I was taught that soil fertility was a process of the chemistry and was a product of the chemistry and physics of the soil. But we've learned a lot in the last few decades about the role of soil life, soil biology, in essentially as a co-equal partner. And if you think about the trinity of chemistry, physics, and biology, we need to bring the biology back into how we think about managing soils. And if we do, it would compel us to rethink some of our practices and to rethink our tendency to rely on products as replacements to replace ecological processes that we can foster in the soil with different practices.
Yeah. So, growing a revolution, the practices you're talking about that are around the world, they are actually primarily information driven in the sense, these are about decision trees, about making wise decisions that will lead to positive outcomes for the whole community, for the farmer, for the people the farmer feeds, the neighbors of the farm. And it's a different thing from saying buying things to try and make more money. And they amazingly seem to leave the farmer and the farm neighbors and the eaters out of that equation.
Yeah, I mean, one of the I've encountered a surprising amount of interest in the ideas of changing practices among conventional farming communities over the last 10 years since I wrote Dirt and started speaking at farming conferences. In part because I think one of the things that got squeezed out of the American farming system over the last century is the importance of the economic success of our farmers and our small farmers. I mean, they're kind of squeezed between the rising costs of all the inputs that they rely on, the diesel, the fertilizer, the pesticides. Those in real dollars have gone up in cost as they have come to depend more and more on them because they've compromised the life in the soil that was formerly relied on. And as an interesting side thing, if you use a whole lot of nitrogen fertilizer on an already really fertile soil, you're just throwing your money away. You don't get any real effect out of it. And so there's a real reason why the whole sort of dependence on chemical fertilizers arose after all the land soil degradation that I wrote about in Dirt. It took a few centuries for the Western world to really sort of want to go that route and to discover how to use it. And it's obviously a more complicated story than that. But farmers have been squeezed between the rising costs of inputs, and they've been so good at specializing and growing so few commodity crops that they've depressed their own prices. The corn prices have been on the floor for a long time because there's such an overproduction of it. And so if we reversed thinking about it and thought about, well, not about how would we set up an agricultural system to produce an overabundance of cheap commodity crops, if instead we thought about, how might we actually improve the profitability of small farms? We'd encourage farmers to diversify. We'd encourage farmers to use low input approaches based on practices they could learn and teach without high capital requirements to implement. And we'd create markets to distribute that food more widely. There's all kinds of connections embedded not only in our farming practices, but how we've set up things like our distribution networks, our slaughterhouses, the way we provide access and connections between farmers and eaters. And there's a lot of interest and a lot of discussion and a lot of reform going on in those areas today that I think are as important as how we treat the soil. But the foundation for a more positive outcome in agriculture, I think 100 years from now, is going to be to choose the path of rebuilding healthy, fertile soils as the goal of agricultural practices.
And so it's interesting. One of the people I'll be talking to for the symposium is from Denmark, and he's told me about their social network, and there's a tremendous amount of support in that country on a governmental level for organic farming, and a serious commitment, $150 million, which in American dollars would be about $19 billion. And we don't see $19 billion being committed to take America organic. So, yeah. But they're doing that not just for the people who will eat the food, although that is certainly part of it, and they believe it will positively impact healthcare, and they believe it will positively impact water quality and air quality, and they believe it'll positively impact climate change. I'm curious, do you think that part of the revolution seems to me that we need to get not just the farmers involved, we need to get the eaters involved?
Yeah. Well, we need to get our eaters, and we actually need our policymakers to start actually caring about and following through. We need. I've noticed the biggest sort of drive and impetus for agricultural change. There's sort of two big drivers in the sort of in the marketplace. I mean, the organic sector has been the most rapidly growing part of agriculture for a decade and a half, 2 decades now, and that's mostly consumer driven. People want better food. People don't want pesticides in their food. They want to be eating healthier food. And there's all kinds of ways to sort of look at and think about and argue about that. But I think that the basic idea that people want healthier food is driving the consumer preference end, which is driving the expansion of the organic marketplace. And the other end, in terms of conventional farmers who are going to what in Growing Revolution I called sort of organic-ish farming, farmers who are learning how to forego the glyphosate, learning how to use less than half of the nitrogen and cut down on their diesel bills. A lot of that I have seen the interest has been growing from on-farm economics, the farmers wanting to shell out less for the inputs that they need to grow their crops, because if they can shell out less and they harvest just as much with other methods, it's more profitable for them. So I've seen sort of both the consumer preference end driving things, and I've seen a community within the conventional farming world arguing for change that is bringing them closer to the organic world. What I haven't seen much of is really effective high-level policy guidance in terms of the way we set up our agricultural subsidies, the way we reward farmers, the way that we inoculate them against risk for, say, converting to organic or converting to more organic-ish. There's all kinds of things at a policy level we could be doing that could essentially encourage the acceleration of a transition to farming practices that would build better soil health as a consequence of intensive agriculture. And my hope is that we're going to see in the next few years more policy initiatives to actually try and better line up with the growing consumer interest, the growing farmer interest, and the other part that has worried me that I'd love to see policy action on is how we actually get more young farmers onto small-scale farms growing vegetables in constructive ways near cities where there's populations of people who would benefit from fresh vegetables grown that way. And I'd be a big fan of seeing more sort of urban agriculture, but I'd like to see it done actually in healthy, fertile soil. And given that we waste about a third of the food that makes it into cities today already that never gets eaten, we actually have a supply of organic matter that we could use and either recycle to networks of small farms around cities or even small urban farms in cities if we started recognizing organic matter not as a waste, but as a resource that if we don't put it back on a farm, it gets wasted.
Yes. I think it was Michael Pollan who said, until we can light up the switchboards, we don't have a food movement. And I would say until we can light up the switchboards, we're not going to change the laws.
Yeah.
God bless the enlightened politicians, wherever they might be, but they can't do it without a power base of eaters, of consumers who care about this.
Yeah, they tend not to lead, they tend to follow.
They tend to follow.
Yeah.
And that's fine if they will follow.
Yes.
We need to lead. So I do think it's so important that we find our voice and that we talk to each other, and eventually the politicians will find out. I do agree with, Al Gore's statement that it's not enough to change the light bulbs, we need to change the laws. I agree with that. We do. And we know that we are being pushed by governmental policy into many corners that we don't want to go into.
There's an example. The first popular audience book I wrote was actually an environmental history of salmon called King of Fish that looked at how salmon in Europe and New England and out in the West Coast where I live have been degraded and decimated historically by overfishing, dam construction, and habitat degradation and hatcheries, all that. But there's a real interesting lesson there in terms of political action in the fights over the damming on the Columbia River. The biggest advocates for not damming the Columbia River for actually modifying plans so as not to harm the salmon of the Columbia. The biggest opposition to that came from Congress people from Missouri and Midwest states. It was not people in Oregon and Washington who were originally fighting for the salmon. Today it's kind of flipped. It's still a major cause in the Northwest. But one of the things that I think we need to do, or that needs to be done to actually engender the kind of policy change that agriculture needs these days, are for people in the cities, people not in rural areas, to actually become concerned about agricultural policy because of the kind of food that they're getting and the kind of things that the way their food is being grown is doing to the land, both on farms, but also downstream, the kind of effects on groundwater, the effects on the Gulf of Mexico. And I think that, the degree to which we can get people to understand that the way we treat the land, the way we treat the soil in how we grow our food affects not only the food they get, it also affects a whole slew of other environmental issues, but that it makes a difference for the quality of their food. That food doesn't just come from the fridge or the grocery store, that there's a process. And if you think about food and its very basic elements, it's carbon and it's carbon dioxide and water captured through photosynthesis and made into sugars. But that's not all there is in our bodies or our plants' bodies or in food. There's mineral elements that come from the earth, come from the soil. How you get those things to dance together biologically into forms that actually can nourish a living organism, that's the magic that happens in the soil. And that's really where I think if we can get people to understand that and think about that and recognize the importance of it, you can start to ground why it's so important in terms of how we grow our food is just as important as what we eat.
Great. So let's go there, David. I know that you and Ann have been working a long time, doing a lot of research and pulling together research from many people to look at the connection between soil health and human health and nutrition. Nutrition being the link. So can we talk about that?
Sure. I mean, if you think about how those mineral particles get out of the soil and into your body, first they got to get into a plant and maybe into an animal, and then they get into you. And there's other things that happen along the way. So what we've been trying to do is that we've been trying to take those connections from soil health to crop health to livestock health to human health. There's a whole lot of little dots to connect along the way. It's hard to go straight from soil health to human health today because you walk into any grocery store and where's all the food from? I mean, it's from all over the world, right? And even if you have sort of a farm's name on the label of something, it may be from a conglomeration of farms. Then you don't know sort of which one it came from, and soils are really variable the world over. So it's really hard to basically directly do any kind of studies or experiments that connect those dots straight without thinking about the stuff in between. So what Ann and I have been doing for the last couple of years is to take each of those steps and to actually dive into the science and look at, okay, how do things go? What impacts soil health? What is soil health and what impacts it? How does that affect the health of crops? And how does that affect the nutritional value of crops? What's sort of in crops? And then the same thing with livestock, of going from what the livestock are eating, how does that affect what gets into their bodies and what their bodies then can offer to our bodies, and how the changes that have happened in recent times agriculturally have affected how many of those kinds of things are getting into our bodies and what the medical science literature says about how important that is or not. And as you might imagine, it's a complicated, tangled mess, but we're tracing those threads through. And so, one section of the book will be on soil, one will be on plants, one will be on livestock, one is on people, going basically along that path of following solar energy coming in, getting into shaping life in the soil, getting into plants, and the pieces along the way. There's a lot of stuff we're drawing on from soil science, from agronomy, from botany, from animal husbandry, veterinary science, immunology, cancer research. There's a whole slew of different fields we're trying to draw from and look at those connections. And it's turned into a fairly big project, but it's a really interesting one because I think you can draw those threads all the way through. I mean, the kind of stuff that Sir Albert Howard and Yves Balfour and J.I. Rodale were arguing for in the 1930s and 40s, that soil health equates to crop health, equates to animal health, equates to human health. You can draw a thread through that argument that actually holds water in terms of what we've learned in the almost century since then, in terms of the science, both soil science, the botany, animal husbandry, and medical science. But it's not simple. It's a complicated story, and we're trying to turn it into not only a technically rigorous and defendable exploration of what the science says, but also into a good story. And then for one example there's a farmer that we had worked with in northern Oregon who had 2 fields where he was growing wheat, and he wanted to know whether or not he was a conventional farmer doing a glyphosate fallow kind of rotation, and he was trying to move into more of a diverse cover crop kind of style of more regenerative-ish farming. And he wanted to know whether or not that would affect his yields. And so he did a trial to the same kind of wheat in the same soil right next to each other in the same year. And I went down to give a talk in his neighborhood, saw his talk, or talked to a person who had been working with him on it. And they'd found that they could basically go to this newer style, these different practices, and not lose any yield, but spend far less on herbicide. So, with the cover crops, they were working for him, and he wanted to know, what's it doing to the wheat? Is my wheat any better? So he sent us samples of the wheat for the second year that he ran that experiment. So it'd been again sort of the 2 years of either diverse cover crops or a glyphosate fallow rotation. And we took the wheat down to a lab in oceanography that a colleague has. We ran the full sort of metals profile on those two samples. And, there were big differences in things like zinc. There's more than 50% more zinc in the crop that had been cover cropped than the one that had been glyphosated. And when you dig into sort of the literature on what both, cover crops do to soil life in the soil and what glyphosate does to life in the soil, it's not a terribly shocking result. It is consistent with what we kind of might expect. What was shocking was how fast it occurred, because you're not changing the zinc content of the soil in 2 years. The zinc's in there, right? The trick is getting the zinc out of the soil particles and into the wheat. And bringing the mycorrhizal fungi back, bringing soil life back, is a quick way to do that. And so we started then exploring, what does the literature say in terms of experiments that have looked at the effects of fungal abundance and diversity and different species on getting metals out of the soil and into different crops. There's a lot of science there that suggests that we should be disturbing, if we wanted to increase, say, our mineral micronutrient content in our grains, a good way to do that is to disturb the ground less and to fertilize it less and to cultivate beneficial life in the soil. So there's examples like that we go through for each of these links.
Good. So I want to just point out to people who are listening who aren't maybe familiar with this conversation that you said in order to get more of these beneficial minerals in the food, you're fertilizing less.
Yes, exactly.
So it's not that you're adding those minerals to the soil. They're there. It's
right.
You're figuring out how to work with the life in order to release them and get them not just more, but in the right balance.
Yeah, exactly. And one of the weird little tidbits of science that we found in researching this is that you can, there are people who have been experimenting with, adding, soluble zinc fertilizers to raise the zinc content of wheat. What they tend to find is that when they put it foliarly, they put it on the leaves, they can actually up the zinc content, goes right into the plant. When they put it in the soil, it doesn't help because the delivery system's out of place. And so I tend to think of the bacteria and the fungi in soil as miners and truckers that are kind of like, getting those mineral elements out of the soil particles and delivering them to the plants. And so a lot of the problems that I think we have on a lot of agricultural land today in terms of what has been thought to be sort of mineral deficiency in the soil, for a lot of the micronutrients in particular, the ones we don't need a lot of, but that we really need, we need them a lot, we just don't need a lot of them. Most soils have enough to support agricultural productivity in a way that would be nutritious for people. The problem is getting it out of the soil and into the crop, and that's a job for bacteria and fungi.
And adding more of those minerals doesn't necessarily give you more in the crop.
Exactly. If you don't, if the delivery system is out of whack, then it doesn't necessarily help.
And the delivery system is this beautifully complex circus, this zoo of living things.
Oh, it is. I mean, if you look at the way that some of the studies have looked at how fungi are getting minerals out of the soil and delivering to the plants, it's actually a combination of certain bacteria living around the tips of the fungal hyphae that are actually mining the minerals out of soil particles. And then the fungi are taking them to plants and delivering it in exchange for sugary exudates. There's communities of life that are involved in sort of complex orchestrated dances through which, sort of all parties are benefiting. The idea of a symbiosis, the kind of thing we know from the above ground world with like pollinators and flowers, right? They need each other. They're two totally different life forms that have over evolutionary time figured out a way to meet each other's needs in a way that they both benefit. There's all kinds of relationships like that happening in the soil that back when Sir Albert Howard and Eve Balfour and Rodale were talking about these kinds of ideas in the early days of the organic agricultural movement in the West, the science wasn't there to actually understand how it worked. It was more science fiction. They couldn't provide a mechanism to explain, well, what do the fungi do for to the plant? What does the plant do for the fungi? Why would, and even Sir Albert Howard was arguing that plants were consuming the mycorrhizal fungi that grew interconnected with the roots. It was Eve Balfour who was saying, no, What's happening is that the fungi are converting things in the soil into metabolites that then the plants would take up. And we now have a much more sophisticated understanding of those linkages. They were kind of on the right track, but they didn't have a mechanism. And that's what I've been impressed by in researching You Are What Your Food Ate, which is the probable title of the new book, is how much of the science has fallen into place over the last 80 years to explain those links and connections that were widely dismissed at the time they were first floated, in part because they couldn't be explained.
Yes, so the observations were actually accurate in terms of cause and effect.
Well, at a gross scale, cause and effect. Yeah, exactly.
Yes, that they saw that if they used the green manures and cover cropped and minimized till, that in fact the crops were getting healthier, the animals were getting healthier.
Right.
And they didn't have as good an explanation as we have now. And I'm sure in another 80 years, should we survive, we will have an even better explanation of how that's working.
It's always a fun intellectual exercise to wonder about what are the things that we think we know today that in 100 years people will be chuckling about how misguided we were. We can only hope that, like them, we're kind of looking in the right direction, even if we have an incomplete understanding. And that's one of the fun things about being a scientist, is that it's always incomplete understanding. So there's never a shortage of work to do.
So you said at the beginning of this part of the conversation that you were trying to define, soil health. What is soil health? Have you got, a relatively short explanation that could sum that up right now?
Boy, the way I like to think about it these days is that it's easier to define in its absence than it is to actually define what it is. It's kind of like our own health. I mean, we know when we don't feel healthy, right? You feel sick. We have a word for it. And I think that, in great part, many of our agricultural soils are sick. They're not as healthy as they once were. But if you were to try and sort of pinpoint, a single measure of soil health or a single crisp definition, that's where it gets actually harder. And some of the definitions you'll find in policy documents, to me, sound a bit wonky and not all that informative. But you would have to basically gauge it, whatever you would measure to determine it, should you want to go that route. You would have to gauge it by essentially the context you're in, in terms of what actually makes for a soil are the geology of the material that it came from, the climate that it's in, the kind of vegetation that's growing in it, the other organisms, animals, and that live on or within it, the microbes in it. And so you have to kind of gauge it contextually. But put simply, I think that there's sort of two key measures that I like to think about. One is just the amount of organic matter in the soil. You can think of that as sort of the batteries that drive soil health. And the other is the nature of the community of life in the soil, its abundance and diversity. You put those two things together, and if you have an organic matter-rich soil for its context and climate, so you wouldn't have the same level in Arizona than, say, in Iowa, right? You'd have to adjust for that. But that the more organic matter and the more abundant and diverse the community of life in that soil, the healthier the soil is. But I think if you're looking for, a real definition of soil health that's fairly simple for most people to understand, I like to flip it on its head and basically go, an unhealthy soil is one that actually needs a whole lot of other supplementation to be fertile.
Okay. So the further that you get from that complex system with an ample supply of organic matter, the less healthy you are.
I would definitely endorse that view. Yeah.
Yeah, that's great. So in your experience and in your research, the first step on this linkage, and it's almost not the next step, because I don't think you can have that healthy soil without the active involvement of plants.
Yeah.
So plants are the next thing. What makes a healthy plant? What makes an unhealthy plant?
Yeah, and so if you look at essentially how plants have evolved in partnership with fungi in the soil, plants can only, their big trick is photosynthesis, right? They can harvest sunlight, and it's like, this is a biggie. What What microbes do is that they have such incredible biochemical diversity. They can consume one thing and turn it into a metabolite, their waste products, that's something completely different. I mean, that's why we have beer and wine, right? We feed microbes sugars, and they make booze for us. And that's one of the sort of early discoveries about why people started thinking, oh, well, maybe microbes are kind of important after all. And then we discovered that they can cause diseases, and our sort of perception of them has been flip-flopping ever since. But if you look at what it takes to sort of, if you think about the natural defense system of a plant, what keeps a plant healthy? They're stuck in place. They can't run away from a predator the way that an impala can. And so there's sort of two grand strategies in the botanical world for defense. One are things like thorns. And if you're familiar with Devil's Club up here in the Northwest, if you grab a piece of Devil's Club, you quickly learn why the devil word is in it, because you get thorns all through your hand. So there's those physical kind of defenses that we all kind of know about. The other kind of defenses for plants are biochemical defenses. And so plants will make things called phytochemicals that can actually make them taste bad to certain predators. And there's partnerships that have been outsourced in effect by plants. So there's examples where when a herbivore, for example, will nibble on a certain plant, that plant will send out chemical signals into the soil, exudates. It will exude chemicals into the soil that will attract certain microbes that can transform them into other compounds that the plant will take back up and either help repel the pest by making the plant taste bad, or stimulate the plant to produce phytochemicals that help repel that pest. And there's all kinds of chemical signaling and communication that goes on between plants. You can think of them as having a chemical language, which has taken us a long time to kind of figure out how to decipher. We're still trying to decipher it. But those linkages are there in part to actually spur relationships with their microbial partners. And so a plant that's growing in healthy, fertile soil has a more robust defensive system than a plant that's growing in essentially relatively sterile and infertile soil, because it has all these offshore partners, these little chemical factories in the soil that can make things that are useful for the plant in its health and in its defense. Some microbes in the soil, for example, make plant growth promoting hormones that then get swept up back into the plants. They'll consume exudates from the plant, turn them into growth hormones to make the plant grow. Plant gets bigger, captures more solar energy, puts out more exudates into the soil. They both benefit. So one of the things that when we think about the effect of farming practices on plant health, we've got to think about what are the natural defensive systems of the plants and how do those practices either hurt those systems or help those systems. And too much disturbance and too much, if you acidify the soil, for example, by applying too much nitrogen fertilizer, it can depress communities of beneficial microorganisms in the soil. Glyphosate can do the same thing. It may not affect the total numbers of bacteria in the soil, but what matters is the community structure. It's not so much how many are there, it's sort of who's there doing what. I like to think of it in the context that if you had a whole city full of geologists, we'd all starve to death, right? We'd argue about rocks and we'd never be able to figure out how to grow food. And so in the soil, you want that diverse community that we know of in our human communities actually allows us to do more things more constructively together. The soil is kind of a parallel system with that. And so if you want to grow, healthy, fertile crops, having healthy, fertile soil is a step on the way there. And then you can take that same argument into livestock in terms of, well, what's in those plants? Are they full of phytochemicals? Are they full of vitamins? Do they have the right minerals from the soil, or are they short on them? And then you can trace those sort of all the way then through to what are the effects on human communities, with the caveats along the way for how complex each step actually is. But that's why it takes us a couple years to put a book together, is to try and dig through what those connections are and to try and sort of really understand what we can confidently say and where the gray areas still remain.
Yeah, that's wonderful. I love your title, "You Are What Your Food Ate." It's a basic human phrase, "You are what you eat." And I think even that phrase is actually sort of cast aside, because what we're eating now is Twinkies and gummy bears and and nachos. But
Right.
to think of it as you are with your food aid, and that's where your nutrition comes from, and that's where health comes from.
It's the foundation for it. I mean, because there's all
Yes.
kinds of things that affect our health, right? There's our genetics.
Yes.
There's our choice of, of whether we're eating those Twinkies or we're eating bananas, or there's the what we eat. But, if you really look at the foundation.
The air we breathe, the exercise we get.
Exactly.
They're all real factors. But if you try to do it without the food.
It's the foundation for health, right? The foundation for good health is what your food ate. And so that's the basic message of the new book, is that it actually really matters how we farm, how we grow our food. Because that's tracing the path of food out of the soil and into our bodies, or however one would make food if one wanted to go the technological route. It actually matters to what follows through and sets the foundation for all those other things, our diet, our exercise, our genetics, to play out on. If we've got the building blocks for health, we have a better chance of actually maintaining it.
Yeah. I was on a Zoom conference at Tuck Business School about new food tech, and they were growing meat, and it was all these different companies, and I got to ask a question. I typed in questions, and mine got a lot of votes. And I said, they talked about very important that they chose, I think, 5 or 6 metabolites that they turned out to be very important to add to the process. And I said, well, what about the other many thousands of metabolites that an animal would take up in a soil system? And they said, well, we didn't look at those because we were only interested in the ones that created taste. And these were the 5 that we figured created taste. And I said, well, I wonder if the other thousands of metabolites might have some purpose that might be important to us.
Yeah, that might
and
do
he was
things.
he was stumped. He said, wow, we never thought of that.
Wow.
I was impressed.
Yeah. No, but I mean, you look at just like milk. There's something like 400 different kinds of fats in milk. And, and if you look at the way our thinking about fat, as whether it's good for us or bad for us or what it does, just how that's changed in the last 30 or 40 years, it ought to make one very cautious about thinking that we totally understand, exactly how to engineer what we need in food, making it from scratch in a laboratory. Nature has a long history of dialing in relationships between soil life and plants, and between the forages and grazing animals, and between humans and the plants and the animals that we've come to integrate into our diets in different parts of the world. And one of the fascinating things is how different many of the diets in different parts of the world actually are, and tracing sort of what may actually be in them that's helping those communities of people to live on diets that are really different than how other communities of people in other parts of the world maybe are consuming. And we're finding some commonalities in the book that I think are going to be really interesting to trace through, and look at how the way that we have been growing our food in the last 80 or so years has really fundamentally altered the nature of part of what's getting into us in ways that probably does make a difference for our health.
Yes, I mean, that has been a revolution, and not necessarily a beneficial one. We're the guinea pigs here.
Yeah. And what's amazing is how much good science there is sort of hiding out there in technical journals that hasn't really been put together in a way that would allow people who are non-technical specialists to really understand the links and connections and think about it. So, for the next few months as we try and finish this book up, which hopefully by the time anyone sees this video, we'll actually be done with the book, although it takes a while to actually get it out to people. But, there's a lot out there to actually try and integrate, and we're trying to pull it together and digest it, make sense of it, and relate it in ways that are relatable.
Yeah. David, can I ask any advice you might have to, most people are not farmers. Farmers are now, once most of the human race was a farmer, but now it's a small percentage. Could I ask what your advice would be for a civilian, for a non-farmer, as they're making food choices in the world? I know there's no simple answer here.
Yeah.
But what would you say with all you've learned?
There's a couple things. The first one is think about what you're eating, but you also want to go beyond that and think about understanding, if you can, how the farmers whose food you're eating, how they actually grew it. And that's sort of a leap that's difficult to get at the grocery store. We have labels. There's the organic label. There's the real organic label. There's other labels that people are proposing putting out. They don't. Some of them don't always tell the whole story in terms of the way the soil was treated. But there's only so much information one can bring into sort of point of purchase to try and make a decision. What Ann and I have done is that she's buying as much of our food as we can at farmers markets where we can know the farmers. We can know what they're actually doing, and so what are your practices? Because that then gives us more information. But there's other simple things in terms of that are sort of fairly well known but well grounded. Eat less processed foods. Eat whole grains, not processed grains. Eat fresh whole foods. There's reasons that some of those fats are in milk. So we've gone back to drinking whole fat milk. But if you look at some of the differences in dairy and meat, there's real differences. There are real differences between grass-fed and grain-fed animals. So thinking about and trying to connect back to the way food was produced is actually a good way to try and optimize the nutritional benefit from what you do end up consuming. And then obviously, eat more fresh whole foods than Twinkies is always good advice.
Yeah. So, David, you've been generous in serving as an advisory board member to the Real Organic Project, and I am so grateful that you came today. Do you think that the Real Organic Project has a chance of succeeding in terms of trying to reclaim something important, valuable that's being lost?
Yeah, I think that, I look at sort of two levels of success there. One is with the term of sort of reclaiming the term organic. And that is where, in writing Dirt, I looked at the degradation of farming in the Roman heartland 2,000 years ago, where the soils were devastated. The Pontine marshes were built, that the harbor of Rome was silted in from the devastation and soil erosion. The overly aggressive tillage, even in organic agriculture, can destroy the land. So I think that if you look at sort of the roots of the modern organic movement, it was founded on the idea that healthy, fertile soil is what is at the basis of good farming practices. And so the degree to which the Real Organic Project can basically reorient the sort of, the organic agriculture project writ large back to the basics of, are these practices actually enhancing soil health, maintaining soil health? And I've been on an organic farm in California almost exactly a year ago, where the soil was just completely beat up. And we were actually visiting another farmer who was very progressive in the way that they were treating their land, right nearby, and growing organic produce that was incredible in really good soil. So I think that the Real Organic Project can make great headways in terms of reclaiming the term organic back to more like what it was intended to actually represent by those who were originally formulating the ideas behind it. But I think the bigger question is can we reform agriculture this century along the lines of making all agriculture more organic-ish, if not more like the Real Organic Project? And therein, I have the seeds of optimism, because I think at the root of both is the idea of rebuilding healthy, fertile soil as a consequence of intensive agriculture. Some of the most intensely productive farms I've been on in the last year working on this new book were very small-scale organic farms with absolutely incredible soil. And I've also been on farms around the world that have used more regenerative practices that weren't really organic, but that were organic-ish, that had really improved their soil. And if 100 years from now, we can look back, the society looks back and goes, boy, the choices we made in the 21st century to reprioritize soil health as the foundation for our agricultural system, if that has a positive response in 100 years, it would be awesome. My big worry is that we choose to keep going down the route of technological alternatives to rebuilding the basics, healthy, fertile soil, because we can only run so far down that road before that starts to fall apart on us. And I think we're kind of we're getting close to that now, with yields from conventional agriculture stalling out, and the problems we're seeing with soil acidification, where we're now having to lime soils that we fertilized with nitrogen, using one fertilizer to offset the detrimental effects of another fertilizer. That's not a good long-term strategy. So my short answer is I guess that's my long answer. My short answer is, I'm an optimist by choice. And I think both the Real Organic Project can make headways in the organic community, but I think it also can help point a beacon towards the direction where agriculture as a whole needs to go over the next 100 years, even if we don't convert all farmers to sort of real organic practices. The closer they get, the better off we'll all be.
Absolutely. So, David Montgomery, thank you so much for spending this hour with me. I really appreciate it, and I am really looking forward to that book. I've been looking forward to it for seveul years now.
Well, hey, thank you much. It's been a pleasure to talk to you, and I've been looking forward to getting the book done for several years now.
Good.
Thank you for listening to the Real Organic Podcast. We hope that you'll subscribe, tell your friends, and leave us a review on iTunes, Google Play, Spotify, or wherever you found us. A video version of this interview, as well as the full transcript with links related to today's conversation, can be found at realorganicproject.org/episode 27. Please join us next time for an interview with David Grinspoon. He's NASA astrobiologist and author of Earth in Human Hands, Science Friday's 2016 Book of the Year. To find a Real Organic farm near you, visit realorganicproject.org/farms.